Fertilizer. Man versus nature. Comparing synthetic and organic fertilizers. The goal of our research is to determine which type of fertilizer, synthetic or organic, is more sustainable while looking at the three pillars of sustainability, as sustainability is defined as whatever is best apt to promote the needs of the present without compromising those of the future. In order to do this, we need to analyze the life cycles of each alternative and compare them accordingly. Our functional unit comparison is shown in kilograms per hectare in order to compare the crop yield and effectiveness of the fertilizers against the amount of fertilizer needed. Other endpoint categories to analyze include eutrophication, energy use, and the disposal of other emissions. In order to create an accurate comparison, we will specifically look at fertilizer and its application to rice crop in Northern California. Inputs span from the energy and water needed for extraction and processing of the raw materials to the transportation of the manufactured product. Outputs include emissions and waste, which occur during all stages of each fertilizer's life cycle, some more than others. Looking at each stage in the fertilizer's life cycle, we can see how they affect each pillar of sustainability and their significance to that triple bottom line.
Traditional fertilizers have originated from organic materials such as manure and green waste. Modern fertilizers, however, have evolved to be a synthetic composition, containing the same main nutrients, nitrogen, phosphorus, and potassium, as organic fertilizers, but overall have a different makeup of filler material in ratio to the nutrients themselves. The filler material in synthetic fertilizer is composed based on the cost of the material and its effects on the active ingredients in the fertilizer. Synthetic filler may include sand or granulated limestone because of its weight, low cost, and lack of adverse effects on the fertilizer. Time release mechanisms may also be present in synthetic fertilizers, such as coatings over the active ingredients. In comparison, organic fertilizers usually lack filler material, time release mechanisms, and inactive ingredients. Because fertilizer is either synthetically fabricated or organically collected, the best alternative to one fertilizer is the other. Both have positive and negative qualities.
The metrics we established to analyze the impact of the two fertilizers based on the three pillars of sustainability are the nutrients, being nitrogen, potassium, and phosphorus, in units of kilograms per hectare, the energy input in kilowatt hours, and the soil, air, and H2O emissions in kilograms. We developed these metrics based on the parameters of our life cycle inventory. The life cycle stages of the product we account for with our metrics are extraction and processing, transportation and storage, operation and maintenance, and the end of life. The development of our metrics and the life cycle inventory are two critical parts of our life cycle assessment of the fertilizers. With the goal of promoting the needs of the present without compromising those of the future, and the scope being a rice field in Northern California in mind, we assess all of the life stages of the fertilizers. From there, we use our LCI results and make an impact assessment of the life stages in terms of energy use, CO2 emissions, eutrophication, water use, human health impacts, and solid waste generation. After we compile all the information necessary for an accurate and complete life cycle assessment, keeping in mind the limitations of software accuracy and the information that is available to us on the topic of an interest, we are able to understand which fertilizer is more sustainable according to the three pillars of sustainability.
An important factor that dictates what type of fertilizer that people choose to buy is the cost. In order to determine which of the two fertilizers is really more costly, we need to adjust the nutrient ratio to be the same and consider how much of the types of fertilizer would be needed to fertilize the same amount of land. According to the results of our cost analysis, we found that the cost of organic fertilizer was more than twice as much as synthetic for year zero, but as the years continue, the cost for synthetic will begin to catch up to the price of organic based on their lifespans. The chart you see is the total cost of each fertilizer by its components. In our net present worth analysis, we are assuming that our costs do not include everything but fertilizer and application costs. Our net present value for synthetic comes out to be $14,712.48, while our net present value for organic is $19,813.13.
So based on the definition of sustainability, which option should be chosen? Socially, as the goal of fertilizer is to promote crop yield and increase the food supply, synthetic fertilizer proves to be more viable. Organic fertilizer is more expensive, raising the cost of rice at all levels. In order to meet the need of feeding the population, synthetic fertilizer is most apt and best suited based on its ability to have a constant and cost-effective output. Economically, the overall cost of synthetic fertilizers is much lower than organic, making it an obvious economic preference. In terms of energy use, however, it is much more intensive, making a case for organic. In the end, it is apparent that synthetic fertilizer is economically advantageous. Environmentally, eutrophication is an important environmental endpoint indicator, in which organic fertilizer contributes to more than synthetic. The concentration of even vital nutrients becomes toxic at a limit, and is a measure of its eutrophication. Synthetic fertilizer does not reach a concentration threshold like organic. Instead, synthetic fertilizer leaches not only NPK nutrients, but other filler materials and chemicals that may not occur naturally and have toxic properties. Overall, synthetic fertilizer is more environmentally unfriendly than organic, especially with proper application and maintenance.